Media delivery has become the industry standard over the past 10 years. Tape deliveries have become antiquated and typically only request for redundancy or used for legacy systems. Often you'll find file delivery specification in a deliverables document. Strict adherence to the deliverables document is essential to ensuring your media is actually played back and viewed in the way in which it was intended. Endpoint requires your media to be encoded in such a way that their data center can process the media effectively. As a general rule, the more consumer in nature the endpoint it is, the more flexibility there is in the deliverables. As a reminder, all professional outlets will have a deliverable document or web page to reference. Always ask for this prior to creating deliverables. Some of the deliverable media that can exist is, for example, social media. Social media websites such as YouTube, Vimeo, and Facebook can handle SD and HD resolutions in case of 2K, 4K, and above. It's also known broadcast outlets such as NBC, CBS, ABC, Fox, PBS, and others have strict guidelines for delivery. And also there is feature films, mainly Netflix or maybe Prime or HBO Max. Non-broadcast professional video outlets, such as Netflix and Hulu, have defined their own standards for media delivery as they are not beholden to traditional broadcast infrastructure and legacy set-top boxes. Creating the files. When it's time to create the files, you have to ask yourself some questions, such as what type of video are you going to do and how are you going to compress it, since you have to put it on some media or social media. The key to a good looking and delivery is to create your final deliverable from the highest quality master file. Recompressing media files that have already had a wrong compression will yield a worse looking media file. Much like making a photocopy of a photocopy, generational loss can occur with each subsequent recompression. So it is important to start with the highest quality file available. The highest quality file from which all of other versions will be generated from is often called mezzanine file. The easiest way to create a mezzanine file is to export from the NLE project itself. This means either exporting from within the NLE or exporting through the software application that understands a project file, such as Adobe Media Encoder or Adobe Premiere projects. Accessing the original media when creating a delivery means you are generating a mezzanine file from the highest quality files available. It means the source footage. Now, what if my source media is very compressed? The exception to this is all of your media is compressed. Perhaps I'll shot on one cell phone, then exporting to a cell phone format will further reduce the quality of your file. This is because lightweight codecs like H.264 are long GOP and extremely lossy, and thus tend to break down following subsequent rounds of recording. In this case, we will want to create a long GOP mezzanine file that is perceptually lossless as possible. Often, this becomes a mezzanine file in a ProRes or DA for HD. As the industry moves forward and gets more development on their compressed encodes, we have to take into account that there are new formats and codecs that have been developed to handle the increase of an image that could help you with your endpoint video. Some examples of these ones are HEVC, AV1, 4K video, HEVC, H.265, and etc. Now let's go with the audio. So obviously you have to have a good audio. So we must encode our audio in a way that not only retains the audio, but it can also be decoded and played back with the viewer. Perceived audio quality, just like video quality, can vary incredibly on where and how the end user decides to view the media. Is it being heard through a small mobile device with headphones or in a movie theater? Each media outlet will manipulate your audio. Audio layout in your NLE. Most NLE support mono and stereo audio editing. Some even support various versions of editing or mixing surround. Together, most NLEs understand that professional audio manipulation isn't best suited for an NLE toolist. The video editing toolset is prominently frame based and centered around video argumentation, not audio. There are audio laws. For example, when you're watching a TV show and suddenly the audio of the volume of the audio it comes like in waves, so it goes up and down. And this is a major problem not only for the enjoyment of the media you're consuming, but because your hearing damage can potentially occur at high volumes. Due to this, the Calm Act, it means Commercial Advancement Loudness Mitigation, was put into law by the FCC to ensure that broadcast television aired content at similar volume levels. Mixing to be in compliance with the Calm Act is important to ensure your audio isn't rejected by the NOC.
Closed captioning. Captioning both open and closed serves many purposes. Open captioning or time segment transcriptions and descriptions of the audio are permanently burned into the video frames of your finished media and are thus always visible. Closed captioning, on the other hand, follow the same basic concept as open captions, but are optional viewing for the end user. In essence, these closed caption files can be toggled on and off by the end user if the media player supports it. The key to giving a user this functionality is to not only ensure the media player supports closed caption media files, but also embedding the caption files into the correct place within the media file in its wrapper so it can be accessed. What type of captioning? The most common use of closed caption files is for various languages. This allows your media to be consumed and comprehended by viewers who don't speak the language spoken in your video. Many VOD outlets will request one or multiple translations to broaden your media's reach. Standalone caption files can take many formats. These formats have varying degrees of usefulness. Some handle visual formatting for the text, with options such as bold, underlined, or italicized text. Many flavors even have various fonts that can be used, plus placement of the text on screen. While there are dozens of formats in use, let's cover the most frequently used formats for web and broadcast. Subrip, Web BTT, scenarios, closed caption, time test markup language, EBUSTL, caption center, real text, synchronized accessible media interchange, captions Inc., Shida ASCII, Shida binary, and CI binary. Embedded or sidecar. Embedded, while in all-in-one embedded file sound like the most complete option, is not always the easiest. This is because of the wrappers the media resides in a QuickTime Move wrapper or an MXF wrapper file. Have different specifications as to where the captioning is referenced within the wrapper. Sidecar. A sidecar caption file is a standalone, self-contained file that it means to be referenced by a media player that understands the relationship between the closed caption file and media file. This is primarily done through the timecode present in the media file and its matching timecode within the caption file. The media player will access that and sync the playback during viewing. Check for quality control. Quality control, also known as QC, is the method of checking your deliverable to ensure the meet the requirements outlined by the deliverables document from your endpoint. QC is not only a visual check, but also includes scanning the files for technical issues like legal audio and video levels, proper time code, and file metadata. Just to name a few, for broadcast, QC is not largely an automatic process where specialized software applications QC your media and generate a report with issues and their respective time code values. Note that visual QC is subjective as opposed to pass or fail stamp. Quality control can encompass hundreds of potential issues. Some common QC flags include bad or dead pixels, visible production equipment, compression artifacts, composing errors, luminance shift, color levels. Example: Rec 709 or Rec 2020. Incorrect audio levels and noise. ADR levels and sync. Incorrect timecode and frame rates. Missing caption files. Incorrect rubber audio placement and language tracks. Poor quality footage, stock or low res source material. Wrap it up and export. First, as we discussed earlier, exporting a misnice file from your NLI or finishing system is preferred, so you have a master file with which to create your various deliverables versions from. This ensures that you have the highest quality to start from. The next step is creating the individual version for your delivery. We now have several options and tools available to create these files. Hardware or software? Hardware. This method requires the usage of baseband connection, that is SDI cables, or even legacy component or composite connection hardware. Transcoding also requires a video in or out device, such as those offered by AGA Video System or Blackmagic Design. The cables are connected from the video in or out output of your editing or finishing workstation into a purpose-built transcoding appliance which will create your files. Software transcoding is by far the most accessible solution for most users because it can run on whatever computer you already have. However, it is not without its codec. Like music can be licensed if the codec is not freely usable by the public, then the manufacturer needs the licensed codec for use by software manufacturer. Such is the case with Apple's ProRes codec. While the ProRes codec can be encoded and decoded on virtually any Apple computer, Apple has not issued a blanket license to Microsoft Windows. Send of the files. Now that your media files are created, we need to deliver the files to the endpoint. Most BOD platforms have web page based platforms for groups of files. For large files, however, web based uploads can be slower and less reliable than optimized connections. HTTP is also not as secure as other transmission methods, meaning your media streaming could be intercepted. To combat this, we have purpose-built media transfer tools. FTP or File Transfer Protocol is a legacy way of transferring files that offer a bit more resiliently than traditional HTTP methods. However, FTP is a two-step process load to a server and the load for that server to another system. This means that transfer time may be longer than a direct peer-to-peer transfer.